K2-18b is a planet that has captured the attention of scientists around the world. Even though its host star is dimmer than our Sun, this planet orbits in what's known as the habitable zone. That means it's at the right distance from its star to possibly allow liquid water to exist on its surface. And where there's liquid water, there's always the potential for life. Unlike Mars or Venus, which are rocky and dry, K2-18b is not just another ordinary planet. It's what's known as a sub-Neptune, a planet that's larger than Earth but smaller than Neptune. This places it in a unique category of exoplanets that are often overlooked but might be far more interesting than we thought. Even more specifically, K2-18b falls into a newer class of planets called hycean planets. This term was introduced by astrophysicist Niku Madsudan from the University of Cambridge. Hycean planets are believed to have hydrogen-rich atmospheres and global oceans that may contain the right conditions for life. Unlike Earth, which has a nitrogen-oxygen atmosphere, hycean planets might support life under entirely different conditions. What makes K2-18b even more fascinating is the fact that the James Webb Space Telescope, JWST, has already detected water vapor in its atmosphere. But that's not all. Scientists may have also found something much more intriguing: dimethyl sulfide, DMS. This molecule, on Earth, is almost exclusively produced by living organisms, especially by marine microorganisms like phytoplankton. This isn't just a chemical curiosity. If confirmed, DMS could be a biosignature, a chemical sign of life. It's a molecule that, as far as we know, doesn't form in large quantities through non-living processes. Dr. Matsudan himself said, this would be the first time that DMS has been detected outside our solar system, if verified. To detect these chemicals, scientists used a method called transit spectroscopy. This means they observe how starlight filters through a planet's atmosphere when the planet passes in front of its star. As the light passes through the atmosphere, it gets absorbed at different wavelengths, revealing the presence of gases like methane, carbon dioxide, and water vapor, and possibly DMS. Dr. Sarah Seeger, a planetary scientist at MIT, explained, this technique allows us to peek into the atmospheres of distant worlds. It's like running a fingerprint scan of alien air. She added, we're finally close to answering the question, are we alone? The possible discovery of an ocean under K2-18b's thick atmosphere is another game changer. If that ocean is warm enough and contains organic molecules, it might support microbial life, similar to the bacteria that thrived in Earth's early oceans billions of years ago. That primitive life laid the foundation for everything that followed, including us. This means K2-18b isn't just a possible home for life, it could be a mirror of Earth's past. Imagine the same type of life that kick-started evolution here, beginning to grow on another planet in a completely different star system. It's not confirmed yet, but these clues are stronger than ever. And this isn't the only planet that scientists are watching. JWST is also studying a group of planets called the TRAPPIST-1 system, located just 40 light-years away. This system has 7 rocky planets, and several of them are in the habitable zone. One of the most promising is TRAPPIST-1e, which has a solid surface and may have water. Then there's LHS 1140b, another target in the search for alien life. It's believed to be a rocky planet with a thick atmosphere and possibly a liquid ocean beneath the surface. It orbits a red dwarf star just 49 light-years from Earth and is considered one of the top candidates for future exploration. What's exciting is how these discoveries are changing our definition of habitability. For decades, scientists were focused on finding Earth-like planets, ones with breathable air and liquid water on the surface. But now we realize that life can exist under very different conditions. Planets with hydrogen-rich skies, extreme heat or cold, or even ones covered in ice may still host life beneath the surface. Even in our own solar system, we have places that might harbor life. Europa, one of Jupiter's moons, and Enceladus, a moon of Saturn, both have subsurface oceans beneath their icy crusts. In fact, NASA's Cassini spacecraft detected organic molecules in the geysers erupting from Enceladus. These are the chemical ingredients of life, and they suggest that microbial life might be hiding in the deep oceans of these moons. JWST is not just looking for life, it's helping scientists understand how planets form and evolve. It's studying the chemical makeup of early galaxies, revealing ancient stars, and giving us new insights into how planetary systems are born. These discoveries are helping astronomers say that we are entering the golden age of exoplanet science. According to Dr. Lisa Kaltenegger, an exoplanet researcher at Cornell University, every time we study a new planet, we are adding a new piece to the cosmic puzzle. We are beginning to see how common life might be in the universe. And this search is no longer just a dream, it's a real scientific mission. As telescopes become more advanced and new data comes in, we may soon find multiple planets showing signs of habitability. Some of them might already have life, while others could be just beginning. There may even be planets that had life and lost it, much like Mars, which once had rivers and lakes. The universe is massive. There are more than 100 billion galaxies, each with hundreds of billions of stars. If even a small percentage of those stars have planets in the habitable zone, that means there could be millions of planets where life might exist. All it takes is one confirmed discovery, and we'll know for sure that we are not alone. But this mission goes beyond science. Discovering life elsewhere would completely change how we view ourselves. It would reshape our history, our beliefs, and our future. It would prove that life is not unique to Earth, that it's a cosmic phenomenon. JWST will continue to bring more discoveries. More strange planets, more chemical signals, and maybe, just maybe, signs of intelligent life. We are only at the beginning of this journey. These findings are also inspiring a new generation of scientists. Kids growing up today might be the first astronauts to walk on Europa, or the engineers who build the first robotic probes to explore exoplanets. The future is wide open, and it's more exciting than ever. So what's next? Scientists are already planning follow-up missions to K2-12B and other Hycean worlds. They want to confirm the presence of dimethyl sulfide and search for other biosignatures, like ammonia, ozone, or nitrogen-based compounds. If they find multiple life-related molecules in the same atmosphere, it would make the argument for alien life almost undeniable. New missions are also in development. The European Space Agency's aerial telescope, launching in the coming years, will study hundreds of exoplanet atmospheres. And in the 2030s, NASA's Habitable Worlds Observatory will take this search even further by directly imaging Earth-like planets around nearby stars. These telescopes will look for weather patterns, cloud formations, and signs of seasonal changes, all clues that could indicate a living, breathing world. Even more fascinating, scientists are discussing the idea of sending interstellar probes to visit nearby exoplanets. Projects like Breakthrough Starshot plan to send tiny spacecraft traveling at a fraction of the speed of light, potentially reaching nearby stars like Proxima Centauri in just a few decades. Dr. Avi Loeb, a theoretical physicist at Harvard, has suggested that if life is found, it would mean the universe is biologically fertile. And that would be the most profound discovery in human history. As this search continues, the possibilities are endless. We may find strange alien ecosystems, new kinds of chemistry, or even life based on elements we've never imagined. Some life might live in liquid methane lakes, like on Saturn's moon Titan. Others might survive in underground oceans, or even float in thick alien atmospheres, feeding on sunlight or chemicals. This is why astronomers believe that the next few decades will be revolutionary. We are moving from asking, "Is there life?" to asking, "What kind of life?" K2-12B is just the start. It's the first planet with real signs that something alive might be hiding beneath its clouds. And as we discover more, our view of the universe will never be the same. The stars are no longer just distant lights. They are gateways to new worlds, some of which might be teeming with life. This is the biggest scientific adventure of our time, and it's only just beginning. Subscribe to our channel and thanks for watching.